Hi everyone. In this video we are going to discuss about our theorem number 4, which is the angle bisector theorem, and the theorem says that the bisector of an interior angle in a triangle divides the opposite side into the ratio of the two sides containing the angle. Now let's take an example here. Suppose we have this triangle ABC as you see in the diagram, and let's suppose that the side AB length is lowercase c units, and then side BC is equal to lowercase a units, and side AC is equal to lowercase b units. And similarly the angle BAC is denoted by uppercase A, so many degrees or radian, whatever you can assume, and angle ABC is denoted by uppercase B, and angle ACB is denoted by uppercase C. And now we are going to draw the angle bisector for the angle A, and let's see how that looks. Here we have drawn the angle bisector, which is AD. It bisects the angle A into two halves. Each of the halves should be half of A, and we have to prove that the ratio of BD is to DC is equal to the ratio of AB is to AC, and in this case AB is to AC is also lowercase c is to lowercase b. So according to the theorem says that if you bisect an angle, then that angle bisector is going to divide the opposite side into the ratio of the two sides that contain that angle. And in this case, what are the two sides that contain the angle A? Well, that is AB and AC. So then BC will be divided into two parts, and the ratio of those two parts, which are BD and DC, their ratio would be same as the ratio of AB is to AC. And next we are going to see how to prove this theorem, right? And now to prove this theorem, we have to draw a couple of additional constructions. So let's do the constructions here. First we are going to extend the side BA in the same direction, and then we are going to draw a parallel of AD from the point C. Through the point C we are going to draw a parallel of AD, and let's suppose that that parallel line segment is CP, and that line actually meets the extended BA line at the point P, right? Our construction is complete now. Now from the construction, as you can see, because AD is parallel to PC, then the angle DAC and angle ACP, they will be the alternate angles between these two parallel lines. If we consider AC to be a transversal, then obviously angle DAC and angle ACP, they will be equal, and of course each of them would be equal to half of A. And similarly, if we look at the angle BAD and angle APC, they will be corresponding angles between the two parallel lines if we assume BP to be the transversal. So assuming BP as a transversal, then angle BAD and angle APC, they will also be equal, and again each of them will be half of A. Now let's look at the triangle APC or ACP, that triangle, right? If you look at that triangle, we have two equal angles. That means that is an isosceles triangle where AP and AC, those two sides will be of equal length, and as we know, AC is actually lowercase b units. So then if this is lowercase b units right here, let me use a different color. So if this is b units right here, then AP is also b units. Next we are going to look at the triangle ABD and the triangle PBC, and because AD is parallel to PC, we can make a couple of notes like this. Angle BAD will be equal to angle BPC, and each of them would be half of A, of course. Again, the key here is that the two sides, which are AD and PC, they are parallel, right? So now if you look at angle BAD and angle BPC, they are actually corresponding angles if we assume that BP is a transversal, right? Similarly, if we look at angle BDA and angle BCP, these two angles will also be corresponding angles between the two parallel sides if we assume that the side BC as the transversal between the two parallel lines. So angle BDA and angle BCP, they will also be equal, and then of course angle ABD is a common angle between the two triangles. So now we are able to prove that these two triangles have all three angles exactly same. That means they are similar triangles. And in this case, we are going to use the concept of similarity instead of congruence. Here we cannot prove them to be congruent, and clearly they are not congruent, but they are similar triangles because they have all three angles exactly same. So they are similar triangles. So I have used the similarity symbol here to indicate that the triangles ABD and PBC, they are actually similar triangles. Now we are going to use the property of similar triangles. Now using the property of similar triangles, we know that the ratio of their corresponding sides would be equal. So we can say BC is to BD or BC over BD. First I am taking this lower side right here. So if we write BC over BD, that will be equal to BP over BA, and that will be equal to PC over AD. Now let's focus on the first portion of this equality right here. BC over BD equals BP over BA. So if we consider BC over BD, that is equal to BP over BA. Now using this part of the proportionality, we can say that this can be written as, what is BP? Well, BP is actually BA plus AP. Now what is BA? Well, BA is actually the side length C, lowercase c, so I'm going to use a lowercase c right there. And then what is AP? Well, AP is actually equal to lowercase b units, so let me say plus b right here. So that is C plus B over, what is BA? BA is again lowercase c, so that can be written as 1 plus B over C. And from here, let's see what we can do with this BC over BD ratio. So from here we can say BC over BD. Now what is BC? BC is actually the sum of BD plus DC, so we can write it as BD plus DC over BD, that is equal to 1 plus B over C. Now from here we can write it as BD over BD plus DC over BD, that is equal to 1 plus B over C. And from here this is clearly 1, the first portion will be 1, so it will be 1 plus DC over BD is equal to 1 plus B over C. And now those two 1s will cancel out each other, so we are going to be left with DC over BD is equal to B over C. And from here we can say, well, then BD over DC is equal to C over B, and that's exactly what we needed to prove. We needed to prove that the ratio of BD is to DC would be equal to C is to B, and that's exactly what we have proved right here. Also, let's quickly do another calculation. Let's try to find out the value of BD in terms of ABC, and also we'll try to find out the value of DC in terms of ABC. Let's see how that works. I'm going to do that on the left hand side here. So from here you see we have BC over BD is equal to B plus C over C. So I'm going to take these two portions right here. I have underscored with yellow lines here. So I'm going to write BC over BD is equal to B plus C over C, and if we cross multiply, we will have C times BC equal to BD times B plus C or B plus C times BD. And now what is BC? Well, BC is actually the side length A, so this is actually C times A is equal to B plus C times BD, and from here we can see that BD will be equal to A times C over B plus C. That is an important result, we should highlight that. And similarly we are going to find out the value of DC. Now DC is equal to BC minus BD, and what is BC? Well, BC is actually the side length A, lowercase a, minus what is BD? Well, we just found the value of BD, which is A times C over B plus C, and from here we can say that this is equal to A times B plus C minus AC over B plus C, and that can be written as A times B plus A times C minus A times C over B plus C. And from here you see these two will cancel out each other. A times C, positive and negative, they will cancel out each other, and we are going to be left with A times B over B plus C. So from here we see that DC is equal to A times B over B plus C, and this is the other important result that I wanted to show you. And from here we can see that the length of BD and DC, they can be calculated easily if we are given the values of the three side lengths of this triangle, right? If we know the values of A, B and C, then we should be able to easily calculate the value of BD and DC as long as AD is the bisector of the angle A. So we have proved the theorem, and also we have calculated two important results here. This brings us to the end of this video. Thank you for watching. See you in the next video.